So we have just started our second lecture on control system, right? So in the first lecture, I have introduced, what are the topic we are going to cover, right? According to the GATE syllabus. Okay, so we are just restricting ourselves to the GATE syllabus. So we started with the control system. We defined what is system basically, and we ended up with the definition of control system, and we have seen various definition of transfer function, right? In this lecture we are going to go ahead now, okay, and we will be talking about the different forms of transfer function, right? Like time constant form and whole zero form of the transfer function, right? And from where we get the transfer function, like we suppose we have got the electrical circuits, okay, so we can also find the order of the transfer function, right? Order of the transfer function and so on and so forth. So I hope my voice is audible. So please confirm once if my voice and everything is perfect before I begin the session. Yes. So let me check. Yeah, perfect. It looks perfect. So we shall start now, and the session will be around the basics of control system only. Okay, and today we will be looking at various concept, right? So we have already discussed about what is system, what is control system, what is LTI system, and we have also seen the second definition of transfer function. Okay, that was the transfer function. This is lecture number 2. Okay, the basics of control system is being discussed. We have seen the definition of transfer function is basically the Laplace transform of impulse response. Okay, impulse response. Okay, this was the second definition. Provided the initial condition should be equal to 0. Okay, your system should be relaxed. Initial conditions should be equal to 0. Okay, so your system should be relaxed. Those things we have seen, and one more concept we have seen in the last lecture was force response and free force response. When we will say, yeah, this is going to be the force response when input will be other than the impulse, right? If impulse is being given to the system, okay, so that is going to be the natural response that you have to keep in mind. Okay, so today we are going to see the transfer function to the electrical circuit. Any electrical network will be given. So what will be the form of transfer function, right? So the transfer function to any electrical circuit or any electrical network. Basically, we call that form as a time constant form. Okay, so transfer function will be of the form time constant. So any system basically defined in terms of open loop transfer function, right? Any system will be there that will be defined in terms of open loop transfer function, right? So what is the meaning of open loop transfer function? Open loop transfer function means you will apply the input, okay, and you will not be having any knowledge about the output. Okay, like output will not be, there will not be any connection between output to input. Okay, you are just applying the input, okay, to the system, and you will get some output. Okay, you don't have any knowledge, like your input is not intelligent about the output. That is what the open loop, right? And if there is a feedback, right, from output to input, if part of output is connected back to the input, right, that will be known as closed loop transfer function, right? So we have to understand the standard form of transfer function is what, okay, of any system. The standard, okay, standard of transfer function, okay, of any system is described by the time constant format. Okay, it's described by following. Okay, so please keep in mind the numerator and the denominator will be in the form of time constant. You see here, so your g of s, that is open loop transfer function, we call this as open loop transfer function, right? Open loop transfer function. So it will be of the form, keep in mind this, k times of 1 minus, okay, 1 minus, 1 plus, not minus here, s tau 1 1 plus s tau 2, okay, and so on upon this tau 1 and tau 2 are the time constant of the system, okay, that you have to keep in mind, or the network, upon s to the power n, right, 1 plus s tau a, 1 plus s tau b, and so on, right. So this is what the standard form of transfer function that you have to keep in mind always, okay. When you are trying to find the transfer function from the electrical networks, you will always get in terms of time constant form, right. So gs equal to what, k times of 1 plus s tau 1, this is going to be the numerator and this is the denominator, right, okay. So here these parameters, okay, that these parameters like k and tau are called the system parameter, okay, that where k and tau are called the system parameter, okay, system parameter. Why we call tau as a system parameter? Because tau is basically the time constant, okay. Last time we have seen one RC circuit, okay, the time constant of the RC circuit was what? The time constant of the RC circuit was RC only, okay. So that you have to keep in mind, okay. So it's okay. So you guys can watch this session later also if you are busy right now. So you can watch this kind of a session later because the link will be available. Okay. So my main objective is to record this session so that you guys can watch later, right? Okay. So k and tau are called the system parameter that you have to keep in mind. And this n, okay, this n, keep in mind this n. Okay. So n is basically the type of the system. Okay. That you have to keep in mind. So k is what the system gain, k is nothing but system gain, and tau is nothing but time constant, system time constant, system time constant, okay. So this is very important, and n is basically n tells you the type of the system. You can say this is the type n system, okay. So whenever transfer function will be of the form in the form of time constant form, you can say k times of 1 plus s tau 1, 1 plus s tau 2, 1 plus s tau 3, and so on upon s to the power n, okay, 1 plus s tau a, 1 plus s tau b, okay, 1 plus s tau c, okay. So this is the standard form of transfer function, okay, where k tells you k describes about the system gain, okay, as I told you, k is the system gain here, okay. And tau is basically the time constant of the system, which is a system parameter in fact, okay. So what is the meaning of type of the system that you have to understand? What is the importance of type of the system? What does type of the system tell? Okay, type of the system you have to understand. The type of the system is basically the type gives the number of poles, okay, number of poles at origin, right. Type of the system basically gives you, okay, it tells you about, gives, okay, the number of poles, or it tells you about the number of poles, right, number of poles at origin, okay, because we can also write the transfer function in terms of poles and zeros, right. So you can convert into poles. Suppose in the exam they will be giving you the transfer function in terms of poles and zeros, okay. So if you want to find k, if you want to find time constant, if you want to find the value of the type of the system, so you have to convert into time constant form, right? So type of the system gives an information about the number of poles at origin, right. And what is the meaning of pole and zeros? Okay, so you might have studied a little bit about this in mathematics as well. Okay, I hope you might be familiar with what is the meaning of pole and zeros, right? So you know, given a transfer function, we have got transfer function like ratio of polynomial, you can say, okay. numerator and denominator. So if you're going to equate denominator, right, to the zeros, okay, so whatever value you will get, okay, that is going to be the pole, okay, pole of the system. And if you're going to equate numerator, once your transfer function becomes 0, that becomes the zeros of the system, right? That you have to keep in mind. So type gives you the number of poles at origin. This is very, very important concept, right? And in the exam sometimes they ask, okay, and these kind of concept also will be very helpful when we will discuss Bode plot, okay. The initial slope of the Bode plot depends upon the number of poles at origin, right? So always keep in mind, we are talking about open loop transfer function. We are not talking about closed loop transfer function, right? Closed loop transfer function means the output will be fed back to the input, right? So keep in mind, okay, input will be intelligent about the output, okay, what is happening. But in case of open loop transfer function, input is not having any knowledge about output. Okay, whatever you are giving input, you will get the output. It can be desired, it cannot be desired, but if it is a control system, so it should be desired one, right? Okay, so we will try one question here, and we will try to calculate the type of the system. We will try to calculate the system gain. We will try to calculate the time constant of the system. I believe this is fine. So if you have any doubt, you guys can always let me know in the chat box as well, right? So what I have discussed till now is, we have discussed about the transfer function to the electrical network and the standard form of transfer function, that is k times of s tau 1. So this numerator, if you're going to equate numerator to the 0, so your GS will become what? Your GS will become 0. That is what all these all these roots of the numerator is going to be called as zeros of the system. And if you're going to equate this to the 0, so it will be known as pole of the system, right? Where the system, where the transfer function become crazy, it will become infinite. Okay. So this is very important, k, and tau is basically the system time constant. System time constant. Now we'll take one question so that you guys can be in the practice, right? So question number 1, this kind of question will be asked. Don't think that whatever we are discussing seems very easy, right? Yeah, it is simple, okay, because in the gate examination sometimes questions are straightforward as well. So but you have to get the marks, you have to get the rank, okay. So the question here is, find the system gain, okay. The question here is what? Find the gain. Find system gain, okay. Type and order of, find the system gain, type and order, okay, to the following system. The following system, okay. So let me write here the system here, okay. That is open loop system, okay, open loop system, because we will be talking about closed loop control system and open loop control system, right, where feedback will be also present. Understood, everybody? So yes, so find the system gain, type and order of the following, okay. So I'm just going to write and you guys can comment on the comment box, right? Okay, so here CS by RS is given, CS by RS, which is the transfer function is given as, this is given in terms of pole 0, okay, that is S plus 5 square upon S cube, okay, S cube S plus 2 square, and this is S plus 10, okay. So this is given here, okay, and this is in the form of pole, we call it pole 0 form, okay. This is the transfer function of the form pole 0. So this guy is given in terms of pole and 0 form. How to find pole and 0? Just equate numerator, okay, to the zeros. You will get zeros, okay, and here you will get poles, right? Okay. So as I told you that if you want to find the system gain, that is k, and if you want to find the type, that is n, if you want to find the order, okay, order is nothing but number of time. See, order, what is order, we will see here, right? And the Okay, so whenever you want to find the system gain, type and order, so you have to convert this into time constant form. That is what the very first practice you have to do. Okay, so can somebody tell me in the chat box what will be the system gain here? Okay, so let me carry out the solution here. So please keep in mind this is very, very important. Okay, so this whenever pole zero form is given, so you have to convert into constant form. Okay. So let me convert into time constant form so that you guys can so here what we have to do in time constant form, this should be 1 and tau s plus 1 it should be, right? So we have to take 5 common from here and there should be 5 square common, right? So cs by rs. Okay, so this guy is given in terms of pole zero form. Okay, now you have to convert into time constant form. Okay, in order to find type of the system, in order to find सिस्टम गेन. ठीक है, तो यहाँ से 10 into you take 5 square, so 5 square means 25, so this becomes 1 plus s by 5. Okay, this is s by 5 square upon, from here you have to again calculate. Okay, so here you take common, so it will be 4 square into, from here 10, right? So it becomes 1 plus s by 2 square and this is 1 plus s by 10. Okay, now you can write this as 10 into 5 square upon 4 square into 10, right? 1 plus s by 5 square upon s cube 1 plus s by 2 square and this is 1 plus s by 10, right? So you guys can now calculate what is the value of k. The k value is basically this. The system gain is going to be this. Okay, this is the system gain, right? This is the system gain. I will give you the shortcut as well. Just wait and watch. I will give you the shortcut. Okay, I will give you the shortcut. Yeah, good evening, Hers. Okay, I will give you the shortcut how to find system gain. But keep in mind, whenever transfer function will be given in the form of pole and zeros, right? You have to convert into time constant form in order to evaluate type of the system as well as system gain, right, and the order of the system as well, right? So this is going to be the k. Okay, so k is going to be what, let me calculate separately. Okay, in the next page. So k is going to be 10 into 25 means you can say 250 by 16 into 10, right? 16 into 10, it is nothing but 25 by 16 and this is 5 by even divide now. Okay, so I believe this is fine for you. Yes, so 250 by I think this is 4, right? Yeah, here we have done little mistake, right? So it should be 2 square. Okay, because we are taking 2. Okay, we are taking 2 from here, so it should be 2 square. Sorry, please correct this. So 2 square means 4. Okay, from here you see this should be 4, right? Now it is very simple. What we are getting here is, that is 25 by 4, it means 6.25 will be the answer. Okay, this is the system gain. Okay, yes Harsh, good evening. Okay, so you will get so you don't have to commit this kind of a mistake which I think by mistake I have written. Okay, so please correct that. Okay, so k is going to be this. How we have got k? The very first step is you have to convert it into time constant form and then you can find k. Okay, and can somebody tell me the type of the system? Type of the system. Type of the system is nothing but number of poles at origin. You see here how many poles are at origin. Number of poles at origin is 3. So type of the system is going to be 3. Number of poles at origin. So you have to compare with the standard transfer function you will get. And order of the transfer function. Order of the transfer function will be what? Order of the system, you can say. Order of the system will be You see the highest order, you see as here 3 and this is 2 and this is 1, so you can say there will be 6. 3 plus 2 5 and 6. Okay, so order will be 6 and gain of the system will be okay, will be 6.25. so this is what the first question you can expect in the examination, okay, in all the branches. Yes, her type is gonna be 3. Okay. So this is the first model and the first type which you can find in the GATE examination, and this is very simple question. Okay. So what is the shortcut that you have to keep in mind? Okay. So the very first is, given a pole zero configuration, you have to convert into time constant form. Right? The step number 1 is convert into standard form. Convert into standard time constant form. Okay. Before you conclude what? Talk about type of the system. Then second step is then find system gain, and system gain is nothing but, keep in mind now, system gain is nothing but numerator constant upon the denominator constant. Okay, denominator constant, numerator constant upon denominator constant. Okay, so you see here in the time constant form, what was the numerator constant? This was the numerator constant, right? And what is the denominator constant? This was the denominator. Now you have taken the ratio that will give you the system gain information, and s to the power n is going to give you the type of the system. That's it. Now I will give you one question and you guys have to solve it, right? So though I haven't talked about what is closed loop control system, yes, hers type is 6. Okay, what is closed loop control system, what is open loop control system, but still you should know the basics, right? So okay, so always keep in mind the order of the system, the type of the system, okay, the system gain and all. We always talk for open loop transfer function. Okay, open loop transfer function. We always evaluate, remember this is important note. Okay, we always investigate, we always investigate, okay, system gain type and order from open loop transfer function, right? From open loop transfer function, okay. So suppose in the examination they have given closed loop transfer function, right? Then you have to convert into open loop transfer function, then you convert into time constant form. These concepts are very, very important, guys, which you have to keep in mind. Okay, so we always investigate system gain type order from open loop transfer function, right? Understood. So suppose closed loop transfer function is given, right? Then convert into open loop transfer function. Okay, so keep in mind whenever closed loop transfer function will be given with unity feedback. Okay, so what is the meaning of that? Just I'm going to summarize, I will explain everything later, right? So what this is the open loop transfer function, G of S, open loop transfer function, where input is RS and output is CS. Okay, so CS by RS is GS. Understood. Now you have, this is the open loop transfer function, right? Open loop transfer function. Why we call it open loop? Because there is no connection between output to input. If you are taking part of output feeding back to the input, right, to minimize the error, right? Okay, whatever you are applying, and if you're not getting the same, right, so you just bring back again, okay, and compare whatever you have got, so you can minimize the error, okay, that difference. So understood. So if you are, this is open loop transform. Now you can connect, you can do like this. So this is basically the summary here. Uh, Now unity feedback we are taking, okay, we are just directly taking part of output CS, okay, and directly feeding to the input, right? Okay, this is RS now, understood, and plus minus, and this is the negative feedback basically. The feedback is negative feedback, okay. Here it can be plus also, but we are talking about negative feedback, so yeah. So the closed loop transfer function will be of this form. CS by RS will be equal to GS upon 1 plus GS upon 1 plus, okay, GS. Understood. So if in the examination they have given, closed loop transfer function, right? I will explain how I have written directly from the block diagram, how we have written closed loop transfer function later. Okay. Just for the basics, I'm just going to use this form. That's why I'm writing. So this is closed loop transfer function. If you want to find directly from closed loop transfer function, you want to find open loop transfer function. Okay. What you will do? What is open loop transfer function? This guy is an open loop transfer function, that is G of S. So what you can do? You can subtract numerator to the denominator. Right? So CS by RS is given as GS upon 1 plus GS with H of S is 1. So whenever unity feedback is given, so you can directly find the open loop transfer function. Okay? Open loop transfer function can be found out by applying this 1 plus GS. Okay. Let me use the different color, minus GS. So what is this? This becomes GS only. Okay. What you have to do? Subtract numerator from the denominator. Right? What we are doing here is subtract numerator from denominator. This is the shortcut I am telling you, right? Quickly you can do this, right? So just I'm going to take one question and then we will try to investigate the system gain and okay. So what is the question here? The question number 2, right? Find the type and order to the given. Find type and order to the given closed loop system, okay, closed loop transfer function of a unity feedback system, right? Unity feedback system, right? I will discuss the feedback, positive feedback. We'll talk about closed loop control system. We'll talk about open loop control system, everything. But for the moment, just practice this problem, right? So, closed loop transfer function is given CS by RS. So never ever try to start investigating about system gain, type and order system directly from the closed loop transfer function. This is very important caution I am giving you, right? Okay. Perfect. So CS by RS. CS by RS is gonna be what? 2S plus 5. Okay, this is given in the exam. So S to the power 5 plus 4S to the power 4, 6S cube plus 7S square plus 2S plus 5. Okay, this is caution I am telling you. Many students get confused, right? Because of this YouTube and all, there are many lectures available, so you guys get confused. My main motto and my main session agenda of this session will be to open your eyes, okay, and attack into the problem without any doubt. So this is the closed loop control system, right? So don't try to find the, see, if you're going to see the type of the system directly, you can't find the type, okay, because you can't take anything common from here, right? Okay, as s to the power anything cannot be taken common because there is a constant present. So how can you find this is of the form gs upon 1 plus gs. Okay. So if you want to find the open loop transfer function, this guy is basically the closed loop transfer function. Now you have to find the open loop transfer function. Open loop transfer function. What you have to do? You can subtract numerator to the denominator, right? So I'm just gonna write again. Let me use the different colors so that the 2s plus 5 upon s to the power 5 plus 4 s to the power 4 plus 6s cube plus 7s square plus, right? Now what you can do here is right here, I mean 2s plus 5 minus 2s minus 5. We are subtracting, okay, from the numerator, okay, from the denominator, sorry. So these guys will get cancelled. Okay, so what you have got here is, let me take this guy in the next page, okay, in order to show everything. Okay. Yes, so you can write now 2s plus 5 upon s to the power 5 plus 4s to the power 4 plus 6s cube plus 7s square. Okay. Now what you can do, you can take common from the denominator. S square can be taken as a common, right? So what is the type of the system that you can investigate? So Harsh, can you tell me? Yeah, type is 2. Yes, perfect. Type is gonna be 2. Okay, type is going to be 2. So let me 2s plus 5 upon here s square you take common, so s to the power 3 plus 4s square plus 6s plus 7. So from here you can say type is going to be 2, and what is the order of the system? Hers, can you tell me what is the order of the system? Order of the system is going to be 5. Type you can directly tell type is going to be 2, and order of the system is going to be 5, right? And they are not asking about system gain, right? So needless to find the system gain here. Okay, let's do it. So this is what the story is. So what you have to keep in mind, type and order is not defined for closed loop transfer function. Okay. What important remark you have to keep in mind, type and order. Okay, type and order is not defined for closed loop transfer function. Closed loop transfer function. This you have to keep in mind. So to get type and the order of the closed loop transfer system, you have to convert into open loop transfer, right? So open loop transfer function with unity feedback. Yes. I believe this is clear, okay, and I'm not talking anything related to industry where control system is used and all, right? I'm just focusing on control system according to the gate syllabus. Yeah, in mathematics, okay, in other branch of other subjects, okay, in other subjects you can say from electronics and communication, I will be talking about industries related concept also, like when I will discuss devices, analog, communication, electromagnetics, I will be giving you the real life examples, right? But in this is very easy subject and you have to just get the complete marks. And when I will discuss about Bode plot, so I will tell you the application part of Bode plot, right? Because application is very, very important for you guys. Why application is important? Because in analog circuit, whenever you have to you have to plot the gain of any amplifier, so you need Bode plot, right? So this is very, very important to remember. Next concept is very, very important. The transfer function, I have told you, we have got two form of transfer function. One is the time constant form, okay. One is the transfer function will be given in the time constant form, okay, time constant form, and one will be pole zero form, okay, pole zero form. Understood? So suppose we have got any transfer function, right? And if you're going to equate denominator, okay, if you're going to equate denominator to the zero, right? So that becomes the characteristic equation basically. That becomes the characteristic equation, right? Okay, because that is going to give you the roots of the characteristic equation, okay, and those roots will be known as poles of the system. Okay, those things you have to keep in mind. So denominator terms decides the characteristic of the system, okay, not the numerator terms, that you have to keep in mind. So suppose we have got the kind of a closed loop, CLTF, closed loop transfer function. Closed loop transfer function is nothing but CS by RS, okay, which is given as GS upon 1 plus GS HS. I'm not considering HS equal to 1. Unity feedback, right? Please take down this. I just want to explain some of the terminologies. Later, I will take closed loop transfer function, okay, the block diagram, and open loop transfer function, the block diagram, okay, and then I will explain everything how we have written GS by 1 plus GS HS. बट अभी इतना तो सबको पता होगा, ठीक है, चलो. Perfect. So this, if you look at the denominator part, right? So make denominator equal to 0. If you're going to make denominator equal to 0, like 1 plus GSHS, this is basically known as characteristic equation. Okay. Characteristics. Okay, so you can correct the meaning and all spelling if there is a, okay, let me write again. So you can just remember CE, okay, characteristic equation, okay. So if characteristic equation is equal to 0, right, so you can say that it will give you some kind of a roots as well. The roots of CE, okay, roots of CE will be known as poles of the system. Understood? So this is very, very important, guys. Okay. Roots of C is going to be the poles of the system. Okay. So always keep in mind whenever you want to investigate about the system characteristics, right? The feature of the system. Okay. The properties of the system. So who is going to characterize the entire system? The denominator, not the numerator. That you have to keep in mind. So that is why denominator is very important, right? So suppose we have got CS by RS of the form like this: S minus 10 upon S plus 1 and S plus, you can say 5. Suppose we have got this kind of a ratio of polynomials, right? Like S plus S minus 10, 1 S plus 1, S plus 5. So you can do partial fraction, okay. So you should know the concept of partial fraction, okay, because if you don't know the partial fraction, you can't take the inverse Laplace transform, right? So you should have the basic knowledge about Laplace transform and the inverse Laplace transform, right, which will be taught in the signal and system topic. So if you I mean in general, I'm just writing directly partial fraction and all of this. You can say k1 by S plus 1. Just forget about numerator part, okay. We are not worried about numerator part, right? So k2 upon S plus 5. If you're going to write the inverse transfer function, okay, I mean inverse Laplace transform, right? So this will be equal to, suppose this guy is equal to 1. So ct will be in the form of k1 e raised to power t plus k2 e raised to power minus 5t. Okay. Okay. So whatever the characteristics of the transfer function, okay, the characteristic of the system is going to be decided by what? Going to be decided by the denominator, okay. That is very, very important thing which I am telling. So you can note down here the denominator, Okay, the denominator term decides. Okay, the denominator, this is very important concept. Denominator term decides the characteristic of the system. The characteristic of the system. Okay, not the numerator term. So if you're going to equate denominator to the zero, so that will be known as poles of the system, right? So characteristic equation gives the system behavior. Understood? Characteristic of the system gives the behavior, right? The behavior of, okay, behavior of the system, right? Or you can say characteristic, right? So 1 plus GSHS equal to 0, and the roots of characteristic equation is known as roots of CE. I have told you already is the poles. I believe this is fine for you. So this session will not be of many hours. I will be restricting myself, okay, so that you guys can rewatch. I will be conducting again the same concept I hate. So we have to learn slowly and steadily, right? Okay. So just I'm gonna write the definition of pole, right? So definition of pole here you have to keep in mind definition of pole. Okay, before I start talking about block diagram and everything, how to find transfer function from the block diagram, okay, if any big block diagram is given, so just we are defining these basic things. The definition of pole, the pole is nothing but the negative inverse of the system time constant. Okay, remember this, because as we know that the standard transfer function cs by rs is what, a times of 1 plus s tau 1, 1 plus s tau 2, and so on upon s to the power n 1 plus s tau a, 1 plus s tau b, and so on. So if you equate the denominator here, so 1 plus s tau a will be equal to 0, suppose. Okay, the first pole 1 plus s tau a, which is not at origin, right? If you equate to 0, so here you will get s equal to what, minus 1 by tau a. Okay, the pole of the system, remember the pole of the system is nothing but negative of the inverse of the time constant. What? Negative of inverse of the time constant, right? Negative of the inverse of the time constant. So pole of the system, write down the definition, is the negative of the inverse of the time constant. Okay, the time constant of the system. Time constant at which the magnitude of the transfer function become infinity. Okay, if you're going to put 0 here, so the magnitude of the transfer function will become infinite. The negative of the inverse of the time constant, okay, time constant at which the magnitude of transfer function becomes infinity. Okay, this is very important. So system pole sp is going to be what, minus 1 by tau a, minus 1 by tau b, and so on, where the transfer function, magnitude of the transfer function will become infinity. That you have to keep in mind. Your transfer function become crazy here. Okay, and if I talk about zeros of the system, zeros of the transfer function, okay, so zeros of the transfer function is also kind of negative of the inverse of the system time constant at which the magnitude of the transfer function becomes 0. Okay, the definition is same, the inverse or negative of the inverse, negative of inverse of, okay, inverse of system time constant system time constant, okay, at which the magnitude of the transfer function becomes 0. Okay, you can say here Sg is going to be 1 upon tau 1 minus 1 upon tau 2 and so on, where magnitude of the transfer function becomes 0. That is why we call it zeros of the transfer function. I believe Hers, it is clear. Yes. So you guys can watch these sessions many times. That is why I'm recording, and these sessions are completely private. Okay. तो कीप इन माइंड वन लाइन, रोम वॉज नॉट बिल्ट इन अ डे. आप एक दिन में सब कुछ नहीं सीख सकते हो, ठीक है. आपको डेली एक एक कॉन्सेप्ट सीखते जाना है, क्योंकि वी हैव स्टिल 300 डेज एंड वी कैन विन द रेस, राइट. तो अगर आप ऐसे पढ़ोगे, आपका क्रिस्टल क्लियर कॉन्सेप्ट हो, कहीं भी डाउट नहीं आना चाहिए. देयर शुड नॉट बी एनी डाउट. ओके, द वे आई एम टेलिंग यू, देयर शुड नॉट बी एनी डाउट whether it is math or control system or digital circuits or any other subjects I will be taking. Okay, though I will be teaching all the subjects, don't worry, like this only. Okay, but mathematics will give you around 13 marks, aptitude will give you 15 marks, 28 marks plus this, that is 10 marks. So okay, so pole can affect the system response and system stability. Okay, that you have to keep in mind. So we always will be concerned about system response in control system response and system stability. Okay, these two concerns are always moving around, right? So who is going to characterize these things, right? So system response will be affected by poles. Pole can affect system response and system stability, but okay, but zeros cannot. Okay, but zeros cannot. That you have to keep in mind. This is very important concept, right? And time constant, what does time constant do, right? So time constant gives the system behavior, right? Because time constant depends upon the system component, right? I have also told you the RC time constant, right? So this is R and this is standard low pass filter as well, and it behaves like an integrator, right? So this is R and this is C. So you can convert into Laplace transform 1 by SC and this is R, P naught and Pi. So you can write directly the transfer function, that is 1 by 1 plus SPR. This is 1 by 1 plus S tau. So this tau is basically the time constant. Okay, and this transfer function is given in terms of time constant transfer function form. ठीक है. So time constant can be very large, it can be very small as well, right? So this is very important. So this flow chart you have to keep in mind. The time constant. Okay. What does time constant give, right? Or what does this do, right? So time constant gives the system behavior. It decides the system behavior. Okay, because it is related with the poles of the system. Okay. So time constant can be very large. It can be very small, right? If the time constant is very large, okay, so that kind of the system response will be known as slow system response. Okay, and if the time constant is very small, right, that these things you have to keep in mind. Okay, if the time constant is very large, okay, here I'm just mentioning, if the time constant is very large, you might have seen in clamper circuit, right? In clamper circuit, analog circuit, right? We always see some kind of a condition, on capacitor, the time constant, discharging time constant, okay, the discharging time constant will be very, very large over there, okay, so that the capacitor will not discharge. Okay, if the time constant is very, very large, then it is called slow response system. Okay, then it is called slow response system. Slow response. Okay, because it takes last time to reach the steady state. Why we call it slow response system? Because it will take last time. The zeros only contribute in magnitude of the system response. Yes, it is not going to affect the system response and all. Yeah. Okay. And when we will talk about roots, root locus and other concept, right? So you will also see the effect of zeros and effect of poles, right? When we are going to add, addition of poles and addition of zeros. So how it is going to, okay, affect overall. So this is just a brief introduction. So you have to, study, yeah, just like this. Time constant system we have here. If the time constant is very large, it is called slow response. Sometimes, so practically any system takes 5 tau, okay, to reach the steady state. Okay, 5 tau. So how to write the time constant? Time constant can be found out like this: the negative of, okay, the real part of the dominant pole. Real part of dominant. Okay, what is the meaning of dominant pole? Dominant pole means the pole which is very close to the origin is known as dominant pole. Okay, the pole which is very close to the imaginary axis, right? Dominant pole is the dominant pole compensation, because sometimes called a dominant pole. It is very important concept in the gate examination. Dominant pole based questions are asked, right? So there will be different kind of poles. The dominant pole which is very close to the imaginary axis, right? Okay, the pole which is very close to the imaginary axis. Okay, because there will be real axis, there will be imaginary axis. Okay, understood? So this is very, very important to remember. Dominant pole. So this is the concept, right? And there will be different one more kind of a pole, that is known as insignificant pole. Insignificant pole. So discussion will be continued, okay, from here onwards. What is dominant pole? How, if question is given, how we can apply dominant pole compensation. Some of the PYQ also will take up, which was asked in gate 2014 2014, right? And then we will talk about pole zero and response, system response and everything quickly, and then we will come to the we will take some electrical network and we will try to find the transfer function. We will apply some shortcut, then we will come to block diagram reduction, right? So this is what the basic. Until we finish the basics, we can't start the block diagram reduction. Understood? So we'll meet in the next session only. For this session, this is enough. Thank you so much, guys. If you have any doubt, please ask. Otherwise, we will wind up the session and keep following these sessions. These sessions are highly private. You will not find these kind of a content anywhere. And do follow mathematics. Okay, honestly, network theory is also going on by CKM sir. So keep an eye on that, right? Because the CKM sir has already produced many rankers, okay, in the past. Understood? I have produced this year 87 rank. Okay, one of the student got last year. I have also taught, mentored, in fact, 32 rank. He is doing MTech from AI. Okay, and this year I mentored one of the student, right? So he got 87. We will be catching up soon. Thank you, Harsh. Okay, we'll catch up.